Hello explorers, and welcome to another video. And today I'm gonna talk a little bit about Unix philosophy, and that's why I have this background around me. And when you see where the Unix starts, early 60s, when you have or late 60s, when you have the Unix, and that's a mixed sourced kind of deal, because open source was not really on the schedule back then. Most things were built inside of a company, but code was shared readily. So it was kind of hard to actually distinguish what was closed source and what was not closed source. And then it all built from there. And on my right side you have the green bars where you have everything open source, and behind me you have most of the red parts where it's closed source, and then you have some stuff in the middle. But that's not the core thing I want to talk about today, because I want to talk about the Unix philosophy when it comes to programming. And I think that's a very healthy philosophy, and I think it's something that at least I really use in my day-to-day work. And this philosophy came from two guys in the early days of Unix called Ken Thompson and Dennis Ritchie. And the philosophy is actually something that we still are talking about today in other philosophies all around, but most of the key philosophies in programming were actually invented very early, even before computers were invented. So I will read some of these from Wikipedia, and then talk about the things that they thought was really important in their philosophy, how to build your system or program or tool. Make each program do one thing well. To do a new job, build afresh rather than complicate old programs by adding new features. And that's something I think we are actually doing a lot today. We are building a lot of monolith things, or we build a large infrastructure with a lot of small components and so on, instead of thinking about it as a manufacturer's chain or something like that, where we have small tools that do one specific thing and then actually work to make a cohesive work out of it. And well, if you want to actually do something really fast and is very efficient, then this might not be the right approach. But it's a very good way if you want to build something that is modular and you want to replace things in the chain. Then you can just yank a piece out, rebuild that piece, and put a new piece into it, and that makes your chain less brittle if you have a monolith that you have to take down and replace the whole thing. And the next part is expect the output of every program to become the input to another, as yet unknown program. Don't clutter the output with extraneous information. Avoid stringently columnar or binary input formats. Don't insist on interactive outputs or inputs. So this is really talking about the different way you talk or intercommunicate between different programs or tools that you build. And today we have a lot of different formats and a lot of different things that are standardized to send information between different tools and different programs. So you could use other tools, but they're really talking about keep it as simple as possible and make the output as useful for a new program in the chain as possible. So inputs should be really clear and outputs should be really clear, so that you can build a new program that do the next thing in the chain easily. And the next part is design and build software, even operating systems, to be tried early, ideally within weeks. Don't hesitate to throw away clumsy parts and rebuild them. So this is a part that we today would call extreme programming or programming by prototyping or something like that. But it's the core value of this is that you don't look so much to what you build today and you expect to throw this away. And the more important part is to actually put the program or the code into the hand of the users. Because without actually trying your code and running your code, you're not really sure if you have built the right thing, if your code is robust, and all the different things that are in between. So put the code out there or put the program out there to your end users and get feedback as fast as possible in order to make a better solution. Because we are not looking at the best code and we're not looking at the best system or anything like that. We are looking at the best product to suit the needs of the users. So who better to try the product out and actually validate if it's a good thing than the users? If we build something that is so beautifully coded and so well tested and so on, but the users don't need it or don't want it, well then who do we serve? And the last part is use tools in preference to unskilled help to lighten the programming task, even if you have the detour to build the tools and expect to throw some of them out after you've finished using them. And this is a very interesting thought as well, and something that I usually try to use as well. And if we find a task where you're going to spend a lot of time to create data or create test cases, or you're trying to create something that will help your programming task, but it's not really tied to what you are trying to accomplish, but it will make the journey to the end goal faster, then you should stop and build that tool that will help you to progress to the next step. Even though that tool might not be something somebody else can use, or something that you can reuse. It might be just something that you need at the moment. It's very important to stop, build that tool, and actually get that boost in your developments. So I think these 4 core principles are really interesting and something that I try to use in my daily work. The Unix philosophy has actually been rebuilt and it has been improved, and today you might see a list of 17 rules of how to build programs and how to make things simpler and so on. But I think these 4 core principles are really key in order to make something that is useful as fast as possible and make something robust. So I hope that you liked this video. I hope that you learned something today, and I really hope to see you in the next one.